By default, JavaScript is a synchronous language. That means, our code will execute one line after another, and only one operation can be in progress at a time. As an example, let's look at these console logs. If we save the file, the numbers are printed in the exact order we wrote the statements. But, what if there was some data we needed to fetch from an external API after the first number? It could take some time to fetch, and we don't want to leave the user with an unresponsive app. That's where asynchronous code comes into the picture. It allows the app to continue running while we fetch the external data. As an example, let's use the setTimeout method to simulate an API call that takes 2 seconds to complete. The setTimeout method is asynchronous, so it will run in the background while the other numbers print. If we save and take a look at the console, we'll see that the numbers printed before the text. So, the app continued to run, even though there was a statement after the first number. To simplify asynchronous programming, ES6 introduced promises. A promise is a container that promises to eventually have a value. Let's say your boss promises to give you a raise. You don't know if you'll get the raise, or when. That's a promise, and it has 3 states. The pending state is where you don't know if you'll get the raise. The fulfilled state is where you get it. And the rejected state is where you don't get the raise. We define a promise with the promise constructor. The constructor takes a callback that automatically receives 2 parameters. Resolve is a callback that we can invoke once the promise is fulfilled. Reject is another callback that we can invoke if the promise can't be fulfilled for some reason. We'll create a variable that represents whether we got the raise or not. In a real-world app, this would be the result of an asynchronous function, which might be something like fetching data from an API. Now, if we got the raise, it means the promise was fulfilled, so we want to resolve the promise. We'll just do a string that says, I got the raise. If we didn't get the raise, it means something happened that prevented the promise from resolving, like a 404 error, to the API. So, we reject the promise with, I didn't get the raise. We can do something with the value that's returned from this promise, with the then block. As arguments, we can specify a callback function if the promise resolved. And another callback if the promise was rejected. If we save the file and take a look in the console, we'll see the message, I got the raise. So, the values we return from the resolve and reject functions in the promise is what gets captured in the then method. But, instead of the second callback, where the promise is rejected, we can use the catch method. This is just a bit of syntactical sugar, but it makes the code cleaner and easier to read. It's possible to chain then blocks, one after the other. A good example would be to use the fetch API to get some JSON data from the JSON placeholder API. The fetch API is promise-based, and when the promise is fulfilled, it will return a response object from where we can extract the data. We're receiving JSON data, so we need to parse it with the JSON method to convert it into a JavaScript object. The JSON method also returns a promise with the converted data. Once the promise resolves, we'll have the data as a JavaScript object to manipulate. We'll just log it out to the console. If we save and take a look in the console, it shows the blog post data. So, the code in the second block executed. In the next video, we'll take a look at an easier syntax for promises with async and await. Thank you for watching. We'll see you in the next one.